All right, in today's lesson, we're going to be covering section 8.5, linear, exponential, and quadratic models. So to start this section, you should have received a few handouts. One that has boxes like this. I did pre-write a few things in there. You should have also, on that same page, gotten something like this. Another page, little half sheet that has some calculator information, and then some examples, all of which we're going to cut down, kind of like you just saw there. The examples, there is a third example. We're just going to cut that right off. We're only doing 2 of them today. So we are going to start with identifying types of functions using coordinate points. So I did pre-write in here these tables with our coordinate points and what we're going to be using. We're going to start with the constant function. So a constant function is when each input has the exact same output. So as you can see, each one of these x values all end with y as 4. That would be a constant function. A linear function is when values have a common first difference. That's the first difference, meaning we're adding or subtracting the same value to each point as we go. So for our y values here, 7 minus 5 is 2, so that means we have a difference of 2. 9 minus 7 is 2, so we have a difference of 2. Or rather, we would add 2 to the 5 and to the 7. As we continue, we see that same pattern form. Then the next one we have is a quadratic function. That's what we've been spending most of our time this unit on. A quadratic function is going to have values with a common second difference. So we saw that first difference with the linear function, and we're going to see something similar here. We'll start with the first difference. 11 minus 6 is 5, so we had a difference of 5. 21 minus 11 is 10. 36 minus 21 gives us 15. And then 56 minus 36 is 20. So in this case, we don't have a common first difference. We see that pattern 5, 10, 15, 20. So you probably already know what that common second difference is. We're going to come through here. We have 10 minus 5. So we have a common difference of 5. 15 minus 10, common difference of 5. 20 minus 15, common difference of 5. So we have that common second difference. Our last function here is the exponential function. In an exponential function, we are going to have a common ratio. So this one is a little bit different. We've been working with addition and subtraction for the last few of these. It's common ratio or rate. So if we look at this, 44 to 22, that is multiplying by 1/2 or 0.5. 22 to 11, we're multiplying by 1/2 or 0.5. 11 times 0.5 or times 1/2 gives us 5.5. Multiply that by 1/2, and that gives us our common ratio of 0.5. All right, we are going to take a moment and we're going to glue this into our notes. It's going to be the very first thing right under our heading of linear, exponential, and quadratic models. All right, now that we have that in our notebooks, we're going to go ahead and find this little paper right here that says, recall that a scatter plot is a special type of graph that has points plotted to show the relationship between 2 sets of data. Previously, you have used a line of best fit to model the data, but what do we do when the data isn't trending on a line? Like a line of best fit, we have something called a curve of best fit. And we're going to use that to model these data sets when a line isn't going to work. So here's an example of a linear scatter plot and a quadratic scatter plot. All right, we're going to now glue that right below our identifying types of functions. And then the next thing is going to be to use the calculator. So you should have a calculator instruction that looks like this. Up here, we have to perform a regression online on Desmos. Here's all the instructions. This is how you would type the equation that it asks for. It says to type in one of the expressions. It does say below, but I moved it over here. And we're not really going to go through that. You can try that on your own following the instructions if you would like to. But we are going to be using the graphing calculator. So if you have not yet grabbed a TI-84 calculator, you can go ahead and get one of those. And then we're going to follow these instructions to perform a regression. On the calculators, here's mine. There are a couple things we need to know about this. One, R is something we're going to be looking for. That's called the correlation coefficient. R squared is another thing we're going to look for, and that tells us how well the model fits the data. In order to make the calculator show these things, before we do any calculations, we're going to follow these instructions that I pre-wrote over here. So to turn on diagnostics, we're going to press the mode button, and then we're going to scroll down until we see stat diagnostics, and we're going to turn it on. Mine is already on, so I don't need to do anything here. If yours is not on, you're going to put your cursor on the word on, then you're going to press enter to select it, and then we need to exit out of this menu, and the only way to do that easily is to hit the second button, and then you're going to hit mode again, which is really selecting quit. Okay, so now that we've done that, our instructions for a regression says for step 1, you're going to click the stat button. So we're going to find on our calculators the statistics button, which is 2 buttons to the right of the green alpha button. Then we're going to select edit. It's the very first thing. And we're going to put some X values in L1 and Y values in L2. So on this one, we're just going to plug some random values in here. I do happen to have data in here already. In order to get rid of that, I'm going to press the up arrow until I have L1 highlighted. Then I'm going to press clear and the down arrow. I'm going to do the same thing over in L2, clear and down arrow. Okay, so I'm just going to pop some numbers in here. There's a few, and then I'm going to pop some numbers over here as well. I'm not really picking any in particular, just typing some random values so that I have an equal amount of data in L1 and in L2. All right, so now that I have that, to calculate a regression equation, you're going to hit the stat button again. Then you're going to press the right arrow button to get to the calculate menu. And then you're going to scroll down to whichever regression you're looking for. You could be using linear regression as number 4. You could be using a quadratic regression as number 5. Or you could be using an exponential regression. So this is going to allow the calculator to create that equation for you. You want to make sure that you are picking the correct type of regression. So we just talked about one way that you can do that by using the coordinate points to figure out what that is. Sometimes it's not going to be super clear, and we're going to let the calculator help us out in those situations, and we're going to do a couple examples of that in just a moment. Just for now, I'm going to pick linear regression. This is one that we've done before. So I have option number 4, linear regression, AX plus B. I'm going to hit enter to select that. And then my X values should have gone in L1. My Y values should have gone in L2. I'm going to scroll down to calculate and press enter. And then this would give me my formula right here. Y is equal to A, which is now 0.39, and x plus b, which is now 3.16. And then I have my r squared and my r there as well. Okay, so that was a quick refresher on a regression on the calculator. We're going to take a moment and glue this into our into our notebooks. We're going to fold it, is what I was going to say. So I'm going to take this and I'm going to fold it down so that we can get everything to fit nicely. We're turning this into a foldable. And I'm just going to write on the top here that I have some calculator instructions inside of this. Now I'm going to go ahead and just glue that right into my notebook, right below where we just put our previous thing about our scatter plots. And that is going to be the last thing that we put on this page. Okay, so now on our next page, we are going to put our examples. And in this case, we just have two today. We have the two that we cut out. All right, so on example 1, we have the results of a study comparing the speed of a car with its gas mileage in miles per gallon is shown in the table below. So we have speed up here, that's going to be our x, and then we have gas mileage down here, that's going to be our y. Then it says what model best fits the data. Well, this is data that we do not want to figure out by finding a first or second difference or a common ratio or really linear, quadratic, and exponential. We don't want to use the points on this because we don't have a consistent x value up here. If this was 10, 11, 12, 13, 14, 15, then that would work. But because we're not going up by a common amount up here, this is going to make it very difficult to figure out if we have a common first or second difference or even a common ratio. So what we're going to do is we're going to take this data and we're going to plug it into our calculator. Stat, edit, I'm going to clear out my lists. And then in L1, I have 10, 15, 35, 50, 65, and 80. And then my gas mileage is going to go in L2, so I have 15.7, 18, 22, 28, 24, and 19. Then I'm going to hit, oh, I just noticed I missed the 4 on 24. All right. Now that I've fixed that, I'm going to hit the graph button. And, oh, I can't see it yet. We need to turn our stat plot on in order to graph it. So to do that, I'm going to press the second button and then the y equals button. And that puts me in the stat plots menu. On option number 1, I'm going to select it. Mine does happen to be on. Yours may or may not be. Once it's on, we want to make sure that we have scatter plot selected. X list should be L1, Y list should be L2. And that is going to be queuing to our calculator that we want to graph those points that we just put in the list. In order to make them visible, we're going to press zoom and scroll down to option number 9 for zoom stat and then hit enter. So here's my points right there. This looks like a parabola to me, so we're going to use a quadratic expression. So that's actually the very first thing that we were asked. It says, what model best fits the data? Well, that would be a quadratic. All right, since I need a quadratic regression, I'm going to press the stat button again, and then I'm going to go over to calculate and scroll down until I get to quadratic regression, hit enter. X should be L1, Y should be L2. We're going to go down and we're going to hit calculate. Now we have this formula, y equals ax squared plus bx plus c. That's the standard form of a quadratic equation. We have a as negative 0.0067 0.6, which is going to round to negative 0.01. And then B has 0.668, so that's going to round to 0.67. And then C, we have 9.29, and that's actually going to round us up to 9.3. And then we also have our R-squared value right here. I'm now going to take that information and I'm going to write it as an equation in part B, where it was asking us to find the regression equation and the value of R-squared. So the regression equation is a function. So I have f of x is equal to a, which we found to be negative 0.01 x squared, plus b, which is 0.67 x, plus c, which we found to be 9.3. And then r squared is equal to 0.8897. So this is telling me the accuracy of this equation. The highest this can be is 1. So it's a pretty accurate regression equation. Is it perfect? No, but it's going to be pretty close. All right, now part C says, at what speed will the miles per gallon be the greatest? Well, this is a quadratic. So the greatest value is going to be at the vertex. So I'm going to make note of this, that this is at the vertex. And in this case, we're looking for speed, which is our x. We had speed as x, gas mileage as y. So we're going to be solving for the x value in this function. And there's a couple different ways we can do it. The calculator can actually help us out on this one, but I'm going to choose not to use it. I'm going to go back to how we found the x-coordinate of our vertex in standard form. So we're going to start by finding the axis of symmetry. That's actually all we need to find. So x is going to be equal to negative b, which is 0.67, divided by 2 times a, which is negative 0.01. When we take this and we divide this out, it ends up giving us 33.5. So then our estimate is going to be approximately 33.5 miles per gallon. Or sorry, miles per hour. Okay, so that was example 1. That one happened to be quadratic. Now we're going to take a look at example 2 and see what we get on this one. So I'm going to go back to my calculator. I still have this equation up here, so I'm going to hit second quit, stat, edit. I'm going to clear out my lists. And now we're going to plug in our data. So I have for my x values, time, and then for my y values, I have concentration in milligrams per liter. And we're going to type in 0, 1, 3, 5, 7, and 9 into L1. And then L2, we have 14, 11, 8, 6, 4.5, and 3. Now that I have that data in here, I'm going to go right to Zoom and pick option number 9. And I actually just pressed the number 9 there. I know you can't see that, but you can press the number instead of scrolling down and hit enter if you'd like to. Now looking at this graph, this looks like an exponential curve to me. So that means that I need to use the exponential regression. So I'm going to press the stat button again, go over to calculate, and scroll down until I find exponential regression, which for me is option 0. I'm going to hit enter. I want my x list to say L1, my y list to say L2. I'm going to scroll down and hit calculate. All right, so part A here said which model best fits the data. We did figure out that that was exponential. And then calculate the regression equation and the value of r squared. That's what I need this calculator for. I have A as 13.46 and B as 0.85. and then my r squared 0.9956. So now I'm going to take that and I'm going to plug this information into my equation. So once again, I'm going to have a function, f of x is equal to a, which we found to be 13.46, times b, which is 0.85 to the power of x. And then my value of r squared is 0.9956. And this is very close to 1, which indicates to me that this is a very good regression. My predictions using this equation are going to be extremely close to what the actual values will be. All right. Part C says how much medication is predicted to be in the blood, and that's supposed to say milligrams per liter, after 15 hours. So that means that I'm going to take 15 and I'm going to plug it into my equation. So I have f of 15 is equal to 13.46 times 0.85 to the power of 15. And on this one, I'm actually just going to take that and plug it right into my calculator. So I have 0.85 to the power of 15 times 13.46 gives me that after about 15 hours, we're going to have approximately 1.18 milligrams per liter of medication in the blood. All right, that is where we're going to stop today. I am going to take this and glue this into my notebook, and then we will write our homework at the bottom, which I will do shortly. Take this, I almost glued it upside down. Put that in my notebook. There we go. And then our homework is going to be in section 8.5 in the textbook, practice questions 11 through 19 and 21, and that starts on page 357.